Sondolo Afem Godebe, a PhD student from the Department of Mathematical Sciences, Indiana University, Indianapolis. So we will continue with our class of introductions to mathematical statistics. So in our previous class, we checked some basic, we did some basic revision of some terms that you're supposed to know on definitions of sets and others. You can just try to go through the last video. So don't forget to share, subscribe. Alright, so today we are going to check set functions. So in calculus we are familiar with functions, but these are actually functions of a point. But here we are going to introduce a type of functions, a set functions. Formally a set function, let's say set function, not in calculus now but in statistics. A set function f maps a set C, which is our sample, to a real number, that is f of C is a real number. Alright, so let's check some example. So let's see be a set and in two-dimensional space. And then let Q of C, that's functional, be the set, or be the area. We define it to be the area of C. Okay, so if C has a finite area, then otherwise, if there's no finite area, then otherwise we say let Q of C be undefined. So then we have our Q, then Q is a set function. So if C is x comma y such that x squared plus y squared, so you should know that is a circle at radius 1, then our Q of C, but since our Q is defined to be the area of C, then the area of a circle at radius 1, which is pi r squared, is equals to pi. Okay, so let's check another example. If C, using the same function, which is area, if C is 0, 0, 1, 1, 0, 1, so we have this. So if you check the area of this this look like a rectangle. So let's see, let's have a good look of this. We have 0, 1, 1, so we have 0, 0 here. We have a point here, we have 1 point here, we have 0 here, so we have this, then we have this 1, 1, this is 1, 0, this is 0, 0, this is 0, 1. So if you take the area of these guys, so this is 1, from here to here is also 1, so, and that's this is a square, that's length times breadth, I call it, and that should be This should give us 1. Okay, so let's check another example. If C equals to x comma y such that 0 is less than x, is 0 is less than or equals to y, and then x plus y is less than or equals to 1, then you know that this is a rectangle. No, this is a triangle. So let's have a picture. So we have 0, and then we have a function x plus y is than 1. So when x is equals to 0 or y equals to 1, so and then x plus when y equals to 0, x is equals to 1, so we have our x plus y to be this. So the area under this curve, x plus y less than or equals to 1, that is just area of a triangle half base times height, and that's equals to half because our base is 1, and then our height also is 1, so we have it to be half. Okay, so let's check some other example on this. Let's get this example 2 or whatever. So let's see be a set in 1 dimension space, and then let Q of C, so we want to define our function and be equal to the number of points in C, but take note which corresponds to positive integer. So take note of that condition, positive integer. Then we can say that our K of C is set function. Okay, so let's see if C equals to x such that 0 is less than x less than 5. So for this now, our K of C, the number of points we have here, don't forget 0 is not included, 5 is not included, that's just be 1, 2, 3, 4, and that is 4. And then if C is minus 2 comma minus 1, so based on the condition that our function Q is corresponded to positive integers, then the area of this will be 0 because we have nothing. Then if C is x such that 0 is less than x is less than C, then the function applied to this we have 5 points, because that will be between 1, 2, 3, 4, 5. Alright, so let's check another example. So let's see be a set in 3-dimensional space, and then let K of C, and deal with 3-dimensional, be the volume of C. So if C has a finite volume, otherwise, then let our K of C be undefined. Okay, so thus if we take if C equals to x comma y, 3-dimension C shows that 0 is less than or equals to x less than or equals to 2, 0 is less than y less than or equals to 1, and then f0 less than or equals to z less than or equals to 3. So if you calculate the volume of this set, then you have C's. Okay, so if we check if our C is given to be of this x squared plus y squared plus 7 squared greater than or equals to 1. Since this is greater than or equals to 1, then this is undefined because the volume is not finite. Alright, so let's go to sense function that has to do with integral and then sums. Integrals and sums. Alright, if ABC are 1, 2, and 3 dimensional regions, so we can define our integrals for 1 dimension to be integral a f of x dx, for 2 dimensions to be integral b g of x comma y dx dy, then for 3 dimensions as integral c to be h x y z dx dy z. And then similarly also for sum or sigma, we define sigma, what it's called sum f of x for 1 dimension, and for 2 dimension you have this g of xy, then for 3 dimension we have h x y z and the space of c supports to be c. So let's check some interesting example. Let's go to example 1. Let's see be a set in 1 dimension space and what, and then let key of c equals to sigma and suppose c f of x. So we have where f of x is defined to be 2 minus x and the support of s equals to 1, 2, dot dot dot, and then 0 x way. So let's see if our c, first question now, if c is x such that 0 is between x less than 3, that means that we are moving just for so this implies I want to check when s equals to, just for c equals to x such that s equals to 0, s equals to 1, s equals to 3. So for that now, our key of c will be equals to 2 when s equals to 0 minus 0 plus, which is just the summation, when s equals to. So that means that in our support we have this to be 0. You see that? So this should be 3. So our support here start from 1, but this is 0, so this means this will be 0. Okay, then when s is equals to minus 1, we have 2 minus 1, s is minus 2, and s is minus 3. So if we sum up this, we have 7 over, that should be over 8. So let's check another example. Let Q of C be equals to summation C of X. So where f of x is equals to p of x minus b. This is just like a binomial 0, 1 function. So you have 0x where take note we really have for x 0, 1, any other thing you have it to be 0. So if c equals to set 0, then the Q of C will only be on when x equals to 0, and that will be p naught 1 minus p 1 minus 0. There's no p naught, that is p raised by 0. So here we are going to have 1 minus p. Okay, so let's check. So if C is x such that 1 is less than or equals to x less than or equals to 2, then the only possible contributions to this our function will only be between, if we check here, we are only between 0 and 1, so and 0 is not here, we really have 1. So at other point our f of s equals to 0, so we are only going to consider when s is equals to 1, and there's p1 1 minus p 1 minus 1, that is 0, and that is equals to p. Okay, let's check for integral. Another example, let's say be one dimension, a one dimension set, and let K of C to be equal to integral C exponential minus x dx. Okay, so we want to check find QCI when I equals to 1, 2, 3, and 4. Okay, this for C1 is equals to 0, infinity. Sorry, for C2 we have 0, 2. So you can try out this, but let's check this. So we have K of C equals to, for this point we have is 0 to infinity exponential minus x dx. So if we integrate this, we have minus exponential x is 0 to infinity minus exponential minus infinity minus 0, and then this is equals to 1 because this is equals to 0, this is equals to 0, and this is equals to 1, and you have that. Then for the second, this for C1, for C2. First we have 1 to 2 exponential minus x dx. So you have minus exponential minus x 1 2, and that is equals to minus exponential minus 2 minus exponential minus 1. Okay, and then this exponential minus 1 minus exponential minus 2. So you can choose to simplify that further. Okay, so in our next class we tried to check solution to some selected problem from the textbook we are using. So don't forget to subscribe and share with fellow graduate students in mathematical statistics. Alright, see you in the next video.